The purpose of this video is to review section 2.7 on proportions since we ran out of time yesterday, and I will also introduce section 2.8, which incorporates similar figures. First, we have solving proportions, and I just want to remind you of what a proportion is. Simply an equation that states that two ratios are equal. So for example, you could say that A over B is equal to C over D. But we actually say that more like A is to B as C is to D. An example of this would be a basic equation that you've seen already, and that would be 7 is to 8 as M is to 12. Well, right now you look at this as M divided by 12, so to undo dividing by 12, you would multiply both sides by 12. And as long as you do it to one side, you have to do to the other. So that cancels. So you're left with M on this side, and over here you can simplify. And you would get 21 halves, or 10 and a half, but you can just leave it as 21 halves. If you look at that same problem as a proportion, you would solve it this way. 7 is to 8 as M is to 12. Using the means and extremes, you would multiply 7 times 12 and 8 times M. 7 times 12 is equal to 84. And 8 times M can be written as 8M. Written this way, it looks like a single step equation. And so you would divide both sides by 8 to isolate M. And of course you would simplify that. You divide both by 4, you would get 21 over 2, which is the exact same answer that we had solving it like it was an equation. Let's try another one, solving it using the cross products property. If your proportion is 4 is to 3 as 8 is to x, you would find your cross products. 4 times x is 4x, and 3 times 8 is 24. Here we have it written now as a single step equation, so you would divide both sides by 4, and you get x is equal to 6. Why is this helpful to use this? Well, let me put another one up here. If your proportion is 3 is to 5 as 13 is to b, and if you're only looking at this as a equation that involves a fraction, you need to somehow or think of how you can get rid of this b on the bottom, which we talked about. It's possible, but you know, most people move it to the other side of the equation by multiplying both sides by b, and it just involves an extra step. Well, if you use the cross products property or the means and extremes, then you can just, instead of multiplying both sides by b, you can just use the cross products and set that up as 3b is equal to 13 times 5, which is 65. It saves you a step, and it's a little less confusing. All right, great. Let's try a fun one. You will be able to solve equations that look like this. b minus 8 all over 5 is equal to b plus 3 all over 4. Trying to solve this using what you have previously learned about equations would, it's possible, but it's just much more simple if you know that the cross product property works. So let's just look at this as setting our cross products equivalent to each other. So if I look at this, that means that I have to take b minus 8 times 4. Well, the best way to write this, you're multiplying two quantities, would be to show it using the distributive property. Therefore, when you multiply these two, you would get 5 times b plus 3. Well, you've solved an equation that looks like this. You know that you just need to distribute first. So when you distribute, you get 4b minus 32 is equal to 5b plus 15. So now we're going back a few sections where we solved equations with variables on both sides. I like to work with positive variables, so I'm going to subtract 4b on both sides. On this side, I still have negative 32, and on this side, I have 1b, or just b, plus 15. I still need to isolate the variables, so I'm going to subtract 15 on both sides. So negative 32 minus 15 is negative 47, and on this side, I have isolated b. And you could plug this in and solve it. If you plugged in negative 47 minus 8, you would get negative 55, and that's over 5. If you simplify that, you get negative 11. On the right side, if you plug in negative 47 plus 3, you get negative 44. And negative 44 divided by 4 is negative 11. So there you have checked your solution, and you know that your answer is right. If this wasn't easy last night, I completely understand. We did not have enough time to do enough examples, but hopefully after watching a few more examples in this video, it starts to make a little bit more sense. And remember, as always, throughout this entire course, the first time you see something, it's going to be really confusing and maybe even a little bit hard, but it will get easier. I promise. To wrap up section 2.7, I'm going to do 2 more examples. The first one is n is to 5 as 2n plus 4 is to 6. And I'm just going to solve this using cross products. The easiest way, or the best way, to write n times 6 would be 6n. And then I am multiplying two quantities here. It's 5 times 2n plus 4. And I would need to use a distributive property. So 5 times 2n is 10n. 5 times a positive 4 is a positive 20. And I still have 6n. I'm going to subtract 10n on both sides. So I get negative 4n is equal to 20. My last step will be dividing both sides by negative 4, so n is equal to negative 5. And then you might get some real-world situations where you need to set up proportions. And here is the problem. An 8-ounce can of orange juice contains about 97 milligrams of vitamin C. About how many milligrams of vitamin C are there in a 12-ounce can of orange juice? So in an 8-ounce can, there are 97 milligrams of vitamin C. Well, we don't have an 8-ounce can, we have a 12-ounce can. So as long as you set it up so your labels match, or the two pieces of that information that go together are either vertical or horizontal from each other, you can solve this. So if I rewrite this as a proportion, it is going to be 8 over 97 is equal to 12 over x, because that's what we're trying to find. And then to solve this, you could again use your cross products property. So you get 8x is equal to 97 times 12, which is 1,164. Divide both sides by 8. And your can of 12 ounces of orange juice has 145.5 milligrams of vitamin C. All right, that's it for section 2.7.